Hi, everyone, and welcome to another episode of the Common Lisp Study Group. I'm your host, Ram Bedam with Atlanta Functional Programming. Last week, I introduced you, or the last couple of weeks ago, I've introduced you all to the Environments API, a specification that was provided by the X3J13, that is the ANSI Committee for Common Lisp, that was published in originally the Common Lisp to Language second edition by Guy Steele, but did not quite make its way into the standard. And it provides a way, the API provided a way for a consistent way across multiple Lisp implementations to essentially access an environment object. We've kind of discussed and introduced what an environment object was last week briefly, but it is an object that contains a list of variables, functions, and symbols that comprise a package an environment, in addition to declarations as well. We went through quite a bit of the API last week. Today we're going to kind of finish up some odds and ends. Particularly, we're going to try and go through and see what we debug an issue that we had last week when we were defining declaration as part of using the environments API's declaration function. And in addition to that, we're going to be discussing the Parse Macro. Now, mind you, ahead of time, I'm just going to briefly mention this to folks who are just joining in or it's first time looking at the stream, that for whatever reason, if you have a particular question in mind, feel free to post it in either the chat window if you're joining us in the Hangouts, or those of you who are watching our YouTube live stream, I encourage you to either post your questions in the actual live stream chat, or if you are watching this later, please post your questions in YouTube comments, so that way if there's particular concerns or interesting questions, we can address them at a later point in time. For those who are commenting in the YouTube discussion, we'll discuss them at a later point in time. For those of you who are providing the questions in the live stream, I'll try and act on them as soon as I see them. So this way we can actually get some interesting discussion going. Last time we kind of went through a lot of this simple examples of just simply going through declaring and defining variables and functions and symbol macrolets that essentially extend the API when we're printing in variable information. We created a couple of convenience functions here to discuss how might we end up printing out this information using the CL environments API, specifically variable information to grab variable information, which includes things like, are they lexical variables, are they global or special variables, as you can see here when we print out our good old test functions, whether or not they're constants, whether or not they're defined with symbol macrolets and so forth. So this is particularly useful when you are actually going through and defining this information. Of course, here, as you can see, there's a couple of things that we encountered when we were trying to deal with creating local variables and things like this, which later on we've kind of discovered if you are starting to create local variables, lexical variables that is, and you want to actually provide them within the environment, you're going to have to actually create an environment, which we've done so using the augment environment function. This function, as you can tell, provides a top-level environment upon which we are augmenting from. You may have one or more environment objects already provided, And some of them may or may not have been provided by the nil lexical environment, which is the top-level lexical environment that holds all symbols available in your Lisp listener. And usually, if you are building some of these top-level ones that are disjoint, especially from each other, you are going to have to actually, at the end of the day, still all augment the symbols that are available specifically for the nil lexical environment. This particular environment especially gives you the majority of the common Lisp symbols already available to you in the API. It doesn't require you, by using augment environment, to actually explicitly add the variable symbol macros and things like this here. Now, I'm going to extend this a little bit just based on some of the stuff that we learned last week, just to see what kind of stuff we can also get out of this environments API. Specifically, we've kind of talked about this first function here, this symbol macro let. We didn't actually see the symbol macro let dump out, but we certainly had kind of the structure already provided to us here. And I'm going to go ahead and update this so that we can actually see some of this stuff as we are, going through. So this way you can actually check out, when you're using this API, when you're using a particular, function or not. As you can see here, we also saw this particular thing. We'll make our way through, creating lexical functions and things like this. So to begin with, we're going to go ahead and first extend this example that we have here with augmenting stuff. As you can see, we could provide all the macros that we defined already within some symbol, and then we can actually get them lexically defined. So for example, if we go ahead and add, my when has a macro that we've already defined earlier here, it will then, if we go in and ask for function information about this, you could see certainly, for example, if we go ahead and say print function, did I not? Oh, right, I didn't actually do that, so I have to do this. We can actually go ahead and update this guy and grab in here. We can actually go and do the following. We can do, of course, a MVB, which, in Sly will automatically suggest. We're going to grab our multiple value bindings, get their declarations, and then we can just go ahead and do the same thing that we did last time with function information, but this time when we actually talk about the my_when, we could see here, do that. This guy out here, and we can just see what, hold on 1 second, is not of type list. My apologies. Let's see here, what did I do wrong? 1 second, get that out. And what is not of type list? Why is my_when considered to be of type list here? Oh, right, I have to go and provide also the print information, and we could see here that where is it? Augment environment, macro blocks, my_when cannot be provided here. Let's see what happens when we what's passed into this. Okay, I'm gonna go ahead and provide. Oh, that's right. I think I'm gonna have to actually say this here. We have to quote it. Let's see what happens here. Oh, yeah. Okay, so that was the problem. Oops. Go ahead and import this guy. So now, if we go ahead and if we look at this and we go and grab it, we could see that here, when we print the variable information based on the environment, um, uh, we get, according to this, we have a lexical variable in X here provided. It is local to the actual environment that we're in. So if you see this here, this guy expands into essentially a let form that ultimately calls out to, in this case, SBCL's implementation of the um, function information API. Now, for those of you watching this stream, might be using a different Lisp. Just a fair warning again that your macro expansion may differ, and that is perfectly natural if you're using a different API. Places where the Common Lisp, the language second edition implementation of the API that doesn't exist, are filled with the CL environment's implementation of the API, which uses some code walking to actually determine what symbols are actually available in the running Lisp image, so that it can provide you with the information that they could query from the running Lisp image itself. Now, one question, obviously, most people probably may be wondering is, why is this the only one quoted when we added this, whereas the other two are not? And I'm pretty sure if we add our symbol macro, we'll get the same answer. And in fact, let me go ahead and do that, so that way we can actually complete our exploration of all of these kinds of environment minus the declaration stuff for the time being. Let's do this, and let's add here at the bottom another. So this guy now has a macro let, and let's call this guy simlet, just so that we could distinguish from this. And I'm attempting to actually add some declaration information on this guy for the time being. Now let's go ahead and add here, and more than likely if I add this as is, we're going to end up getting the same error that we had before with the macro, because it is technically a macro. So let's go ahead and print variable information on simlet. Let's see what, here. And let's see what happens. And we'll see that this is not of type list as we expected. And let's go ahead and do that, maximize that, go ahead and clear the output, and let's do this, and let's see what we got here. So, as you can see, interesting, it did not actually give me what I expected it to. I thought it would actually go ahead and give me symbol macros here. Let's see, what is missing here? Symbol macros did not. Oh, my apologies. Again, I have to always remember that I have to do this. One thing to note, as you could probably see from me fumbling around here, is the API, just like all the APIs available to you in the Common Lisp image that require an environment object, the environment itself is actually optional, and that's why I'm able to execute this without having some trouble. So that's why we're seeing this, but we just need to keep in mind that it will not throw an error if you're attempting to try and grab a thing, but you may get unexpected behavior if you're using an environment that you're not expecting to use. So let's see here. Nil, nil. Okay, so we are still getting nil for the simlet macro. why am I getting the similar macro? Let's see here. Do I have to actually provide? No, that still actually did not actually help. And we will see what is going on there. We're just getting a macro. We're actually good there. Let's see here. We got the symbolet at the top. Symbol macro is not actually grabbing what we expect it to. Let's see. Why is that happening? That is asking to retrieve the binding information from, we get it from the environment object. Environment object is provided here. Let me just make sure that in our top level function we are defining it here. So why did this not do what I expected to do? So let me grab this directly and see what happens. This shouldn't be any different than what we're doing before, but you never know what's going on here. There might be some ridiculous interaction between the symbol macro and this will clear that. Let's do this again. This is still giving me no. Why is it still giving me no? If I provide, let's see, if I provide that, it should have the environment in the environment object. So I get an error as I expected because number one, it's not a symbol. Of course, it's not a symbol. It wasn't quoted. Let me just grab that. And let's see here. Within this function, we need to know what is actually available in terms of binding. So let me see if I can actually query the environment directly in the environment API. Let's see. We have environments, we have breakdown signals, we have macro hooks, print gensim. Okay, this is all inherited from common Lisp. Let's see. So there isn't anything specific to the environment API that I can actually access that is not exposed. Okay. The REST bindings. And the body is the forms. Okay. And we have let env. Okay. So we have a list here of all the functions provided, and we're clearly getting what we're expecting to in terms of the macro list because we're getting that. Okay. I wonder. This guy is not currently defined in the... Okay, let me try something here. I think I may have figured it out. Let's us do what we had before here. Okay, so we're going to go ahead and grab this information first. And inside the environment, let's go ahead and define it here. Okay, so we have now defined the macro in this area. Let's see what happens when I do that. So I'm in the environment. I am not providing that. And let's do this. Simlet and ignore that. Okay. What happens? Got nil lexical arguments. Macro nil. Well, of course, the macro is defined in the global environment, in the null execution environment. But let's change that too as well, because although we provided the symbol inside the environment, the thing is this here is not actually creating a copy or anything like that. It's actually going up a level and looking at the null execution environment to see what is defined. So wondering if that's weird. That should have actually. Okay, there might be. Let's see. Augment environment. I think I have to provide a list of symbols, but I may also be able to do something else. Let's look at the API for augment environment. Augment environment. List of symbol macro definitions. Okay, now I know what's the problem. So we have to go in to essentially to create these symbol macros and these macrolets, we have to essentially do a definition of the symbol macro inside the environment definition. So in this augment environment, we need to provide a list of symbol macros, not this way using simple symbol macrolet. Although I'm a little surprised that I couldn't just use a symbol macrolet here. That's a kind of a weird thing here, to be quite honest, just because I would have thought that I could just use a symbol macrolet for this. But we could define this pretty easily. So we could just say here D4D, okay, and what we'll do is we'll follow the definition. So in here, this symbol macro, we have to provide a name, and then we need to provide an expansion. So here is bar. Now if I do this and I provide print symbolet, just to see what happens here, print variable information symbolet. It's going to take in a list of lists, essentially, okay? That's what this is supposed to take. So when you provide the list of symbol macros, you're doing a list of lists, essentially, okay? So when we do this, let's see what happens. We have still some issues. Let's see, what did I mess up on? Let's see. When I do this, interesting. It did not. Let's do this here. Oh, once again, I'm so dumb. Sorry. I am butterfingers here. Alright, so let's do this one more time. There we go. Now it's worked. This is expected. Okay, so as you can see here, in the environment, if we're within the environment, we can actually go ahead and provide this symbol macro. Here has an expansion. You could actually see this expansion if you end up using it. So like if we do print symlet, you will see that this will, whoops, did I mess up something? Is unbound. 1 second. Sorry. If I do symlet, let's see what happens here. I should really, let me go and double check something. I may have my macro expansion knowledge wrong here. Let's do right. So let's do here print here list of symlet. This should work, but it's not. Why is it not working? Unbound variable. This is not a. It's not a variable. It's a symbol. How can I end up using this macro? Did I mess up the macro? No, I didn't think so. I could see it in the environment. Let's see, what did I mess up on here? So we have our symbol macro, we have our but for a symbol macro, it is not actually giving us the symbol the way we expect it to, and I don't quite understand why. Let me try something here, just to make sure I'm not going nuts. Thought it was symbol macro at x bar, and then just do list x. This works, right? Right, and we could do this, and then do this, and we get free bar. Now, here, we have defined a symbol macro, which is the same idea. Let's do this. Let's define a dummy data item. Let's call it, let's do y equals 6 here. And let's do this, equals this. So now everything's in line. And we'll add this here. And let's make this into a let star so we can actually use this definition accordingly. And let's do, let's make this also a list of list xy. And here, let's say first item or something like that is our new symbol macro, and this is going to be nothing more than a call to first on a list. Okay, so now when we do first item, this should now work, but I don't think first item is unbound is now becoming the issue. First item, let's see that, and we have that for, so it says that it's a symbol macro, but it can't do a macro expansion. Weird. This is a macro. To execute a symbol macro, you need to have in the environment env. We can actually look it up. We know that it's local to environment, but to use it, what do we have to do? We need to actually be able to. Okay, so there's a question here first. Is symbol macrolet a special form? Yes, as far as I know, and you can actually look this up. The set of special forms is available to you at your disposal in the hyperspec. But yeah, symbol macrolet is a special form as far as I know. I can actually provide list of, I think it was in the hyperspec, I'm forgetting which section it was. Section 5.1, is that? Maybe, it's in section 3 in the hyperspec. If you actually go look up the hyperspec, the list of the available special forms. It's one of 25 special forms that are available for you. I think 25, right? 18. 21, yep, 25 special forms. So set Q, symbol macrolet, define the def macros are and def symbol macros and define compiler macros. These are not actually special forms. They're just macros that are used later on, and they expand. You can go and look that up too as well. Maybe changes what you could do with it. So comment is about maybe changes on what I can do with it inside other macros. I don't believe they should change inside other macros, but that's actually a good note. I will keep that in mind. Let's try this with our second example, which is going to be a much larger one. Just because with macros being defined within the augment environment, you have to do something according to the documentation, which is specifically you need to define this as a function, a macro function, and a macro function takes in and macro function is specifically, according to the documentation, a function of 2 arguments, which you can get if you end up using CL environments. One second here. Okay. So according to the documentation, what we have to do is to define a macro inside of our environments. We have to do this. We use enclose macro, and there's another enclose here, which I don't know what the difference is. Let me see what the describe CL environments enclose and see what happens. Return a function consistent with the lambda expression in an environment. The lambda expression is allowed to reference declarations and macro definitions in environment, but consequences are undefined if and others are defined in environment. Oh, undefined if lexical variables are defined in the specific environment are referred to by the actual lambda expression itself. Okay. This just means basically that when you're defining a lambda expression with the optional environment, and you can provide additional functions, you can reference the bindings in the environment, but you can't essentially, and it's specifically undefined behavior, you can't essentially enclose the lexical environment and treat that environment and all the bindings in it as a closure in such a way that you can go and modify it outside in a lexically scoped way, right? That's what that means, at least as I understand it. So that what that effectively means, bottom line, is if you end up attempting to modify the environment through the use of this enclosed lambda expression, you're going to end up probably dealing with some interesting implementation-specific behavior. So your mileage may vary depending upon which Lisp interpreter you use. And we'll come up with an example with that too as well. But right now, what we're looking at is going to be enclosed macro, which essentially takes in a name, a lambda list, and then ultimately it's going to a macro definition. Okay, so a macro function is a function of two arguments, and okay, so let's try this. Let's see. We may be able to get away with using just a simple lambda expression of two arguments to create a macro function, but we will see. I'll try this first, and then we'll come up with a closed macro. How does that sound? Let's see here. We have in the two arguments, it's going to be okay. Let's see here. We do essentially backtick quote into use a function of two arguments. So see here. Our macro form of lexical environment it can be expanded into. So let's see if okay, so I can actually do it this way. So I just learned one way of actually defining this, and this is actually a pretty good way of doing this. Okay, so let's do that first. Let's do this. Let's get rid of, go ahead and do that. It's my when. Yeah, let's go ahead and redefine our my when function here again. Def macro my when lambda list cnd pet body, and if we all know, if we do if cond progen body. Okay, so now we have our example here, and what we can do here is we can actually define my when as the following, which is pretty neat, actually. Let's see here. Okay, so we can now actually do comma expand into my when. So this, I think that's correct, right? I just looked into. Oh, right. Let's do another way of doing this. Let's define this in a different way. That's right. This right here. Let's do that. Instead of so this is now a back quote, and oh, this is not a function. My apologies. This is not a function. We could just go ahead and expand this way. So now my when is unbound. Let's just do this. Local when equals my when. Interesting. 1 second here. I thought I defined this already. Let's just go into. Oh, sorry. This is now provided. This is now expanded, so we now have our functions. I'm going to look into our augment environment using this function. Let's go ahead and do this. Local when, and we could define a function. Let's go ahead and do this. Okay, so let's do this. So we have a local when to being this back quote. Cond progen body. Let's see what happens here, because this is supposed to be a macro function. So this should take in examples, and I know it should be complaining about local one not being a list. Okay, right. So let me go ahead and do that. We need to go ahead and make this into a list and slurp this guy So now we have our function, macro function arguments. And let's go into augment environment here. Macro function is a function, 2 arguments. Okay, and the environment. Okay, so I think we're okay here, but it might complain still. First argument is unbound. Okay, so this is actually doing what we're expecting to do, except it's complaining about this guy, which we'll take care of in a second. All right, so now let's go and change my when to local when. Okay, and let's do this, clear this up, and let's run this guy. And you can see now our macros are all defined. So far, we've refactored this now, code that we did last week into a symbol macro that was defined locally, a lexical macro that's defined locally in our environment, a macro that's defined locally in our environment, and a function that ends up that's also defined locally. In our function definition here, okay, as you can see, although the symbol was just copied, you may be wondering why that's considered to be locally defined too. Well, that's because it was copied by the symbol object was essentially copied into the environment, okay? The same thing with our lexical variables that we've defined here, okay? Those lexical variables which are in the outside of the let star are actually what ultimately are used to actually go and create this. Now let's finish off this guy. This, I think, the reason is I think I have to make this into a back quote too as well, since this is a symbol macro. And remember, with macros, you need to go and you have to go and back quote it, not quote it. Otherwise, you're going to end up getting these weird things here, as you can see here. And we're still getting some style warnings because, of course, we're not using A-list just yet. Give me a minute, and we'll rectify that in just a second. And we could see that if we just do simply now print list first item, this should, interesting. First item is unbound. Interesting. It's still complaining about that, huh? This is already here. Let me do this and change this guy to essentially being just a list. Okay. And I'm just going to call this sim list just for the sake of separating the two. And you know, so far we've already seen that we can actually use, actually we didn't actually check to see if we can use local when. So let's just check out to make sure that we have local when. Looks like we do. We do local when 4 is less than 5. Print okay. And we have our stuff. Environments : local when is undefined. It is not undefined. It is actually in the context of our function. And you can see it right here. We've expanded it. So I don't quite understand why it's complaining regarding local when. Let's see again this complaint here. using undefined TOK. It's not, it's a, let's see where we're doing it. Oh, sorry, I just made two buffers. Go back to this buffer here. We could see our, if we go and try to expand this, it's not going to expand. But if we try to run it, it runs as is, which is weird that it's complaining within this function here. Let's see, local when is not actually being looked up. In the environment that we're using it in. But it's actually expanding the way we're expecting it to expand. So this is a couple things that, couple nuances regarding CL environments, because it's not integrated with the rest of the SLI infrastructure that I'm using here to present this library to you, that you need to be aware of. And that is, when you're trying to run this, what seems to be happening is the fact that I think if I ran this directly in the REPL, I would not get this issue. Let's see here. Interesting, I still am. Local environments, colon. Of course, it is not there. It is printing out okay. Let me do this, and let's see if I can run the enclosed macro example that we were looking at, just to see if I fix it using enclosed macros, would that work? I think that's what I need to do now, because now this being unbound is telling me that when we're trying to run it, it's thinking that it's a function call, and the symbol object doesn't actually exist in the lexical, for a function doesn't exist, although a macro exists. So to fix this, I think we're going to have to take this guy. Let's see if I can do it this way. Not sure. We're going to be working through this. Let's see what happens. Okay. Here, CO. First, I'm going to move this guy one level down so we have some room. CO environment, enclose macro. Okay, now what are my arguments? Name, name, local when. My lambda list is obviously cond and rest body. Okay, so we have our name, our body, and our optional E and V, but we're augmenting it, so this should not be needed, and we're gonna generate this into a function. Okay, so now when we do this, now everything actually doesn't look like that. Local when is still not provided. Let's see what happens here. Let's do that. Now we have our body. Okay. And we have our thing. Okay, so now let's see what happens. Still complaining about local when. Let's see what this is saying in the, when I compile this. What is this saying here? Undefined function local when, undefined first item. Well, first item no longer exists, so we can get rid of that. Then, let's see. Oh, got it. So this here, do this, comma hash this, like it said, and then do local one. Okay, what did it complain about? Enclose macro is not a legal function name. Oh, shoot, sorry. That's right, because of the fact that I need to wrap this guy and slurp this. Now we have our thing, and what is it complaining about? Is not a legal function name. Says that it's a name. It's an enclosed macro. Let me take this guy out for a second here. Let's do this for a second, and let me just run this guy as is and see what happens. Local when is unbound, enclose macro. Okay. Might be messing up something here. Let's go and look at some of their tests to see if we can extrapolate a better example than some of the stuff that I'm coming up with here. The reason I have yet to show you some of the tests is because I've been trying to understand some of the tests myself, and they're using it's an older some of the library stuff that they're using, since they do use package, it tends to confuse me a little bit. Let's go ahead and see. There's a way of doing this. Like I said, my preferences tends to be looking at the exported symbols, so I don't accidentally Okay, so there's a comment here about slime and dynamic global variables. I asked for a fresh slime environment. Okay, so just a quick side thing regarding dynamic variables. Well, variables or bindings loaded with a fresh slime or sly environment. Unless you've loaded something into a running image, other than the default special variables already available in the image, there should be no intern symbols that you've written. Now, there is one exception to that rule in the slime environment or sly environment, and that is if you did a save Lisp and die and you're reloading an image after doing a save Lisp and die. At that point, then of course it's like saving an executable to disk, and you're rerunning that executable with the default environment at the time that it was executed, or you paused it in a sense, like if you're using a virtual machine. Okay, so let's get back to this. Let's see here now. It says that it's an undefined function, but it's not a function itself. It has to be a macro function. So defining a macro function, requires to actually go and execute each one of them. But let's see if let's see. It said that in here. Okay, so let's go back up here. Get rid of that. And let's see what this guy returns. Okay, back to enclose macro. Let's see here. Okay, let's do this locally without actually using the macro definitions provided here for a moment, shall we? So here, instead of doing this, I'm going to do it differently, right? We're going to go and use our enclosed macro definitions here. Enclose macro, local len, condet body, our macro itself, body. Now we are going to provide the optional env. Well, we're already in the env, so now we do this, and we look up local len later on. This should all be specified in the environment itself. So let's see what happens. And is it still complaining? Yeah, it is. It's going to say the variable now is unbound. Where is it being used to? Being used in the variable. Let's see here. Okay, so let's do something here. Make this an empty list for the time being. There. Now we have our list. Lambda list is going to be our cond and our list body. Let's do this way. Macro. Let's wrap this to a macro expand just to see if this works, and then we'll see what eval is doing at a later point in time. Because I think evaluation is causing all this grief right now, and right now we don't necessarily need to talk about eval. We could just go through this without going into eval itself. Of course, we need to go and do this, and let's go ahead and wrap this because we have this issue where this does not get properly dumped. Okay, we'll go ahead and skip this guy out. There we go. Now here, let me specify env as our optional thing. And it's still complaining about local len being unbound, even though I've actually bound it here. So that means that this must be mistaken. find something here. Enclose macro. Okay. Let's try, instead of enclose macro, enclose with parse macro. So the one thing is what I'm trying to use is essentially a convenience function. Oh, yes, I will use pretty print. That's a good idea. Thank you. Okay. But this is not, that's not the issue. The issue is here related to enclose macro. So let me try something here. Let's do this. So enclose macro actually should expand to, or is roughly equivalent to, another function that's in the API. That I was trying to avoid doing this, but it looks like they're according to the documentation they're exactly the same. So we're gonna go ahead and do that. And that is, we're going to use a function called parse macro and wrap it in an enclose function. This is what we were looking at earlier. That's the difference between this and enclose macro. Okay, it returns a function consistent with the lambda expression in the environment. So let's do that. Control, and let me clear this up so we can actually do it this way. And, oh shoot. Okay. 3. Okay. Okay. Now we can actually do this. Enclose CL environments. Parse macro. Interesting. Parse macro does not seem to be showing up. Interesting. I thought parse macro was available in the library. Let's see. Parse macro. It looks like it wasn't exported. Don't. This is where we're going into some There Be Dragons territory for folks who aren't familiar with this, but that's okay. Lambda list body, just because we're using it, and then do if conditional progn at body. Okay, so now our second thing is env. Okay, let's see what happens here. And it's still complaining about local when not being provided. Okay, so let me get rid of this for the time being. And then let's get this back to what we had before. Oh, now I see what the problem is. I'm being dumb. I had all this working. It's just I didn't realize I'm debugging the wrong thing. My apologies, folks. This sometimes happens when we're moving around code. But this should now all work, actually. Let me do this. Pprint, okay. Here, this is, let's go ahead and add parse variable information here. Okay. Because right now we're not doing macros there for local len. Local len is not defined in this lexical environment. Let's see this. Still unbound. Let's see. DVD. Let's see this. Still unbound. Oh, shoot. Okay. I will be wondering about this for a while. Undefined function. This is the problem. Okay. So local when says that it's creating a lambda list, but the lambda list isn't actually being created, it looks like. Okay, let's see this. Warning, undefined variables. Undefined variables. So this is actually our problem. So we're going to have to go and figure out why we can't actually go in and use enclose macro. Okay, so let's start with parse macro and work our way up. I think that's probably the easiest way to actually see what happens in this, because one of the things here, and the tests are usually your friends. So let's also open up the test just to see if we can come up with an example as we're working through our tests here too as well in the library. So I think I actually made this oh, sorry, I actually got it from Roswell. It was, where was it? It's going to be in local projects. No, wrong one. This is going to be in source. SBCL. Source. No, this is the wrong one. I'm looking at the SBCL source. That's not what I want. What was it again? Okay. It was in Roswell. I think it was in Lisp, I think, maybe. Let's say Roswell. Lisp. Quick Lisp. This, I think. Let's do that. Installed systems. No, it was in releases. Quick Lisp. This. Okay, let's see here. Yeah. Okay. This is in Lisp, Quick Lisp, Dis, Quick Lisp, software, CL environments. Okay, test. Let's go into the test directory. CLTL2, and let's do macrolet and see what happens there. Okay, macrolet uses CL forms, test extraction, and test def macro, a test macro, and a global function. Okay. Let's see here. Info. There is. Let's see. Symbol macrolet. Make sure info equals self. And let's see. Where is in lexical environment? This isn't much help. Let's see what other stuff is there. Let one, let two, set ignorable, make sure is info. He uses a lot of info variable global parse, but we don't want to necessarily use that because those are specific. I think those are not part of the external API info, at least not as far as I know. Let's see, CL environments, info equals, no, but info equals later on. Okay, so let's continue on with this. Let's keep on debugging this then. We'll start with parse macro and then work our way up. Like I said, looks like there's some examples there that just don't seem to make sense to me right now. Let's do parse. Oh, remember parse macro for some reason is being engulfed, I think, by this guy, but I'm going to go ahead and use this for the time being, work my way up to enclose macro. Okay, so parse macro requires a name. So we're going to use what we had before, and a lambda list. Let's say condition and body. A body, which is what we're doing here. CMD, progn at body, and this time instead of using this, I'm going to go ahead and say prext. Okay, although technically you should use body when you're defining macros. For the time being, I'm going to use this just to make things simple for myself. Now we need to define the environment in which we are adding it into, which is env. Okay, so we have this optional env. This body, which is our body here that we defined, and our lambda list, which should expand to something itself. Local is unbound. So why is this happening here? Let me do this manually here, but let's do the optional one, see what happens. And local one is unbound. Let's see here. Let's do my one. Because my one is bound, because we defined it earlier, but it says it's unbound. Okay, hold on. Maybe I'm misreading this. Parses a macro definition form as found. Okay. It parses it. Okay, so let's say that it parses. Oh, I think I figured it out. I think. Let me just work this through for you guys. Okay. So, let's actually do this in the command line first, and then if this works, then we can actually work our way through. All right. We had our symbol macro earlier. We have our lexical thing. We technically also have our macro, which we had as my when. Okay. Okay. So let's do this here. CL environments parse macro enclose macro. Let's try and close this down again. Macro name, let's say it's my when. Our lambda list, which is what are we passing into my when. Let's say that it is, or something like that. And let's say that we are print okay for our body. Okay, and now we have our env. And this is going to complain saying my when is unbound. But it, let's see this here. Let's try parse macro instead and see what it says about this. It's not a variable, it's a macro. So why is it considering this? So there might be something in enclosed that we're missing. And we'll go to define declaration to finalize all this too as well, hopefully, time permitting. Let's look at enclose. Okay, so let's first look at, let me try something here. Let's see here. An environment, print, let's do CL environments, enclose, lambda, and the lambda expression should take in, say, an A, and it provides an XX. And let's say that we put it in our optional environment, our env. What would it do? It's going to complain about function is not of type list. Lambda expression is not of type list. So why is it asking for that? Let me see. Slide. Search. Hold on. Let me do this. H. And let's see. P. See what the package is. Oh no, that's not the one. MH. References and close. MHR. Let's see this and close. There's no references to enclose. Let's do describe symbol. And this is just returning a function that's consistent to the optional thing. So I want to reference declarations inside of it. Okay, so I'm going to provide a no argument lambda expression. See what happens. Oh, let's do that. Might be expecting that. Let me see what happens. And the function no type list is not a like type list. Okay. Let's see here. There we go. That's the problem. Let's see here. It's not a type list, but if I do this, we end up getting what we expected. This, we do that, just quote it as a list of stuff. It's going to compile with 2 style warnings. One style warning now. And what was that style warning? Oh, instead of undoing that, let's do a list. Boom. No warnings. Now we got what we expected. Okay. So we've enclosed this, but this isn't actually giving us what we want. What we want to do is we want to be able to parse a macro from this guy here. So let's do this. Now we're going to go ahead and do the next layer. Now that we kind of seen how enclose works. Yes, there are 3 arguments to parse macro. One is, hold on 1 second, do this so I can actually have some room. If we look at parse macro, we have technically 4 arguments. We have name, lambda list, body, and environment. The name should be the name of the symbol representing the macro, which for some reason, when I use that, I get a complaint, but that's a weird thing. The lambda list is the actual macro lambda list itself. The body is supposed to comprise the actual body. And the environment is where is the definition found for this particular macro. This should generate a proper macro. All right. So but for some reason it's not actually generating it. And parse macro is supposed to, what it's supposed to do, to be more specific, is that, as the name says, is it should take a macro definition. Okay, so it parses it into a lambda expression of 2 arguments, which is suitable as a lambda function. And then this function itself, and this is what our ultimate goal was, is it's supposed to go into the macro argument um, with the enclosed function. So this guy here should ultimately generate us a lambda function. Let's see where else are we going to see this local. Okay, so there's nothing here. And it's supposed to take Parse Macro. It's supposed to grab this information, but I think what's happening is because we didn't define the macro early on, it's not grabbing it because it's looking for the actual macro definition. So let's say my_when instead, just because my_when is provided by in the null lexical environment, because recall we defined it earlier. And the lambda list is what's throwing me off, to be quite honest. This should the macro lambda list. Let's see, maybe I can do lambda list keywords. That's not what we're looking for. Let me see if I can come up with. Let's see. Let's see if I can use the actual top level test in the environment. Okay, a couple of things that they provided. And let's see here. Declaration. Okay. Let's see here. So if it's not this, and I don't know other than doing this, which is macro expand from the form of my_when cond, and then body. I think this is going to be complaining because I'm using the comma operator without a backquote, so this definitely is probably going to screw things up, but we will see. Actually, I'm pretty sure this is going to complain if I draw this. Let's see this. Yes, it's going to complain. Comma is not inside of a backquote, of course. Do this. And then do that. Let's see what happens. Let's see this. Okay, then do see macro expand 1, then do my_when comma, then run this while spliced. Now this is complaining, of course. And it will complain that my line is unbound again. So we're back to where we started earlier. Okay, I'm going to take a look into what this is going on here in this parse macro thing. This is kind of like one of the reasons why I wanted to go through this exercise and just start exploring through some of this. But looks like there is some work that needs to be further investigated to see what's going on there before I can give you guys a full demo there. One thing I think I can try doing with the time remaining is at least define declaration, because that seems to be pretty simple enough that for the corrections that I did last week, that should be pretty straightforward. So we're going to create a new declaration, and a declaration is essentially custom declaration is something that you'll see something like this. Okay, you can actually provide it. It provides compilers hints. Okay, so we're going to do what we did last time, which is essentially try to put some metadata into our thing. Now, the way we do that is we use CL environments define declaration. We provide a name for this. Let's say we use author, and then what we do is we provide kind of the argument variable that's going to be used to essentially get the values from this. Okay, so let's say args here. Okay, so let's say that this is just going to be name. Okay, just for the sake of example. Okay, or we could say author name. That seems more appropriate. Okay. Here, this is kind of an example extracted from the CLHS definition I've seen on this. If you want to define declarations, there are some ways of actually ultimately defining it. See that ultimately this is kind of what it is. Actually, sorry, not CLHS. This is from CLTL2, the example of defining stuff. So now that we have kind of this defined declaration, the body itself needs to be essentially something that returns two values. Okay, the first value is going to be upon which what exactly is what exactly is actually going to be returned by this guy, okay? And that's going to be a multi-valuable function. The first one is going to be whether or not it's it applies to some variables, a keyword, and it could be either a variable, meaning the declaration applies to variables, a function, meaning that it can apply to functions, and so forth. Okay, question. I couldn't find it. Okay, so there's a question about not finding the parse macro from our experiment earlier. In a nutshell, I was using an uninterned, well, yeah, it's an uninterned symbol. It's there, it's just that it's not exported at the package level. If you want to access the parse macro, and you do at your own peril, because uninterned symbols tend to be symbols that may get ripped out at any point in time. But I'm using it just because of the fact that the parse macro definition is available. It's part of the API, actually. And it seems that the authors felt that since they need to provide a macro function to the augment environment macro, which essentially is an enclosed plus a parse macro, they created this new macro called enclose macro that expands the parse macro stuff into essentially an enclose plus a parse, right? So it's there. It's just that it's not part of the public API right now. I don't know why. Other than the fact that I think they want more people to use enclose macro. The authors of this particular implementation of the CL TL environments API prefer you to use enclosed macro instead. Let's go back to what I was to this discussion here. So now, when we're providing, we provided kind of our name and we provided the argument that's going to be bound to. We now need to provide, obviously, you don't necessarily need to provide an environment variable. You may notice in the definition of the signature that there's an environment variable. That environment variable is just a lexical environment upon which you may want to bind this guy to. But for the time being, we don't really need to do that. But what we are going to do is we're going to go ahead and grab and create a function for this guy that returns values. Okay, so let's do this first, and we can always create a more general version of this, but we're just going to do a simple one just so that we could show you that it can be used. Let's say that we do this, and we define a lambda that essentially does values. And it does that. This is a declare, okay, saying basically that we're not going to actually grab anything in here, and our function, all it's going to do is that it's going to just print to the console what you provided. I think you can actually do that. Which is okay, and wait, let me just make sure that I didn't so I don't even need to do this here, actually. This is an implicit program anyway, so let's do that. Let's do this, and this should, if I expand this, generate what I expect it to. Okay. And let's do this here, print author name. Or, yeah. This doesn't matter if it's pre-printed or not, so we're just going to do that. And we do that, and we loaded it. Let's see if we can declare it here. We're going to add it in our declaration. Okay. We're going to declare author, and let's see what happens here. And let's say author John Doe. All right. Okay. Now, when I dump this guy, you should see compilation failed. What is it failing on? Comma not inside a back quote, line 17, column 36. Comma not inside a back quote. Oh, this guy. Apologies. Let me take this guy out for the time being. Okay, let's do that. And what is this? Oh, wait. Malform declaration specification in. Okay. We do this here and declaration specification. So, well, first, let me do one thing before we do this. Oh, that's right. Hold on a second. This guy can't be in here. It has to be in the environment that I'm defining it in. So, do author will see that. No. Okay. And you can see here that we could spit this guy out. And why is it complaining about it being malformed? It should not be malformed. Let's see here. I may have messed up this guy. And let's see if we can also provide here in here. Okay. Since we've first seen this, let me go ahead and do a destructuring bind of this because it looks like it's that this is giving me a list. So let's destructure it. Let's wrap this guy. Destructuring bind. And say a name author name. Although this is kind of weird because of the fact that it's a single argument here. So, but I guess this could be provided to being multiple authors. But we're just going to take the first one. And let's go ahead and name this guy author name. Now let's do that. And let's complain this. And we get John Doe back, but it's still going to be complaining. Parsing argument, invalid number of elements in John Doe to satisfy lambda list. Oh, okay. At least one expected but got non-list. Let's do this. Here. Rest. UTHRS. Let's declare we ignore UTHRS. And we have that. Okay. Let's try this again. It's complaining about still decal name dot value. Oh, got it. Got it. Because this isn't actually a list. This is a string. So I don't, even though this is giving me a list, it's still treated as a string. So you can see that that's what this problem is here. Now form author specifier. Okay, so there's here a issue with oh. So it's giving me the cutter of this guy. So we need to wrap this because this is a cons. So what the argvar is the name of the variable in which the argument list of the declaration is going to be. That's actually passed in a cons pair. all right, the author, which is the name of the declaration specifier, and then the author name. And what we're going to get is the coder of that, which is actually just a list of the values that are there, all right? So, okay, so there's one quick comment about Parse Macro here that I just noticed. Yes, in the case of SBCL, in the case of Steelbank Common Lisp, CL environments is nothing more than a wrapper to SB-CLTL2. So almost all of those APIs are just delegating their functionality to the SBCL implementation of the environment API. So let's do this. See what happens. We got this. Wrong arguments destruction bind, but I do not have destruction bind. At least not anymore. Okay, hold on. Invalid number of elements in John Doe to satisfy decal name. Satisfied value. At least one expected got non-list. Okay, 1 second. Cons foobar test function. AB. Let's try this a little bit differently. Let's get the actual name. Okay, let's do it this way. Name. Okay. Author. Details. Okay. Now, what we're going to do is we're going to grab this as using a destructuring bind like we had before. We get name at rest details, and then we get author details, and what we're doing is in details we're going to get the name. Okay, I don't know why this is required, but this looks like it is complaining about the author details, car details. Okay, let's just do this, and let's just do this. Oh, maybe I don't need this now. Now that I provided this, let's see. Control this. Oops. Okay, and let's do that. Run this guy. 2 style warnings. Undefined variable, of course, because I provided that. Author details. Okay. Now we've compiled it. Now we provided it should complain about nothing. It's still complaining. Why is there a destruction bind happening here? Must be. Let me do the macro expansion of this guy because this is kind of weird. Here. Let details be the rest of the argument that's in the environment. And let's do ignorable author details. Okay, let's see what happens here. Let's let's do this, and then do that. Oops. There we go. Now do that. And let's compile this, and we'll get still an error. Malformed declaration specifier. Still gonna have to go and figure out what is the details here. Let's see. Ignorable author. Okay. Let me see something here. Let's do this. We're gonna still do destructuring here, like we did this. And just get the list of details here. Okay. And do author details. So now, when we do this, what is happening? Author details is the rest. We're destructuring author details, and then we're just printing out the details. Okay. So this now should not complain, but it looks like it's complaining about still declare author is being malformed. Weird. Okay. I think this is the same issue that I was having with local bind because, local when with my example, because it seems that it's not grabbing it from the environment the way I expect it to. Let me see if I can do this. Well, first, let's go ahead and see if we can grab information about the declaration. Multiple. If I remember correctly, I can when I do declaration information here, it's going to take in the name and the optional environment, and then it's going to return information about the declaration itself. So let's see what happens. Print or pretty print CL environments. Actually, let's do it this way. Since this is actually in the null lexical environment already provided, I will go ahead and try and run this guy directly. Declaration. Information, declaration name, author. Let's see what happens, and we get nothing. But let's see if I could do this here. Not here. Here. And let's provide env here. And let's do that. I think the idea is if we provide this information, it should spit out spit out information regarding what was already provided that neither applies to a variable or a specific function. So it should have provided the metadata that we're just dumping out right now. Let's see if I could just simply do this and get rid of that error. Shall we? Still going to be malformed, right? Yeah, it's still malformed. I have to go and understand why this is malformed. This does not make any sense to me. This is declaration name is author. Argument values is It's malformed because it complains about declare author being malformed, but doesn't provide me any information as to why that is a malformed declaration. Each element of the value, symbol, key value, or symbol is the name of the symbol. But if it's declare, the second value should be oh, got it. It should return two values. Okay, so the problem here is this. I misread the documentation. I have to provide the list of name value pairs. That's the problem. Cons name. Let's do this. Let's do details. Let's just say name here. And we're going to say author name. And we're going to just use name here. Let's say a name, so we know the difference. And we are destructuring it, and we get a name. Now, what is this? Oh, name is never used. Oops, that's what I mean. There we go. So now, this should no longer be malformed. Okay. What did I do wrong there? If the first value is declared, the second value should be a cons of the form key.value. Value will be returned by declaration information for the given key. Let's try that. And that is there. Now we do this. And it is specified differently. Let's see here. Let's try to use this declaration out of any sort of function. This should not work, but it might work. Yeah. Figured that wouldn't work. Okay. When we do this, it says that it's complaining about the malformed declaration specifier. What is malformed about it? Okay, so let me go back to the rules. Okay, let's see. This is a name is going to be the author name. Oh, that's right. I'm not using. I changed the name. Okay, what is this? Oh. Here, malformed and declared. Okay, I may end up having to actually have to reboot my image because I have a bunch of stuff that's already been mapped here. And it looks like we're over time. Let me do this. Try this one more thing, and then if this doesn't work, we're gonna have to continue our coding exercise next time. As we explore this API. One of the reasons why this API is a little bit kind of screwy is because some of this is still kind of new to me in terms of especially custom declarations. So I'm trying to learn this particular piece the last couple of weeks while we're doing this. So forgive me if some of this looks kind of new as you guys are going through it too as well. We're learning together in a sense. Let's see here. Okay, so let me first go and restart in package CL user. Now I can restart it. Gonna take a little bit of a section. Okay, so now I can actually go and load my examples, which includes this environment stuff. I may end up getting something screwy. Ah, yes. Okay. Of course, this is going to mess things up because this is not even defined. Okay. In package CL user restart. Okay. Okay. Now let's try this again. Okay. So now let's get back here. Let me look at one thing, which is this must be telling me that augment environment for declarations requires something else. Information about these. Okay, give me just 1 second. We have an augment environment here. No, we do not. Okay, let's try this. Okay, we have this guy defined. Let's go ahead and define a test function. Okay, that just, adds 2 numbers or something like this. B, and let's use declare and the way we use it is okay. Author name, Darth Vader or something like that. Just to see if we have something going on here. And we define it, and we have it. So we now have a function with the author name Darth Vader. So now let's do CL environment. Let's see here. Let's try doing this. CLENVR. Okay, let's do declaration information on declaration name, author name. Let's see what happens here. This should not work, but we'll see. This should print out nil, but when we get the function information, which we have here, let's go and grab good old function guys. And I know, folks, that I should have made a function on this for printing out function information, since I'm always doing multiple value bind, but for the time being, I'm just making this simple. Okay, so this should get it from the top level environment. Again, we printed this guy out. What does it say? It says that it doesn't have any declarations, even though it does. Let's do this. Let's make this into a function, because again, we could provide at function or at variable or declare for a declaration specifier. Now that we change this, though, we have to actually change the representation of the what's actually being returned by the definition. So in this case, since it's a function, the second value should be a list where each element is of the form symbol key value. Okay, so let's see if we have an example of this here. Okay. Let's try this function, and we're going to have a list. Since this is going to be applied to all arguments, we're going to have to provide a function name that is in there. Okay, so let's actually try a simple list just to see what happens. Symbol key value. So let's do test function. We'll generalize this once this kind of works. Name. Okay. This is there. This is there. What is it complaining about? Test function is not a list. List for the time being. Okay. What is it complaining about now? Author name is also not a type of list. Okay, so we need to have 3 lists here. Okay, so let's do this. And okay, the reason why that we're doing this is because later on we actually go and map some of this stuff out and construct these different things. Each of these have to be their own list. Okay, let's do this. It's complaining about Darth Vader is not a list. Of course it's not a list. It's also okay. Got that. Oh, not that. List name. There we go. There we go. This is not actually what I expected. So if I do this, this is a function. It should actually grab the information about interesting. So what is that about? Let's see here. Why is that not working the way we expect it to? So this is kind of supposed to actually go and create the list of values that we just did. This is attaching author name Darth Vader to our list. And if I just look at test function itself, let's see if I can get the symbol function. Test function. Look at the actual symbol. We have argulists, we have things, but there's no declarations. Okay. Let me go and look at, if I do declare, ignore AB, which is going to cause a warning because we're ignoring stuff. And let's see here. Look at the declaration. The code function does not have any ignored symbols. Okay. Let's see here. Function nil. Interesting. Okay. So sayonara regarding slime and slime kills your Lisp, but it doesn't restart it. Restart Lisp because that is effectively does a sayonara plus a sly or slime in your case, if that makes sense. Okay. It looks like I'm going to have to look at some more information regarding this declaration stuff. So, and regarding the parse macro stuff, which I kind of expected that to happen when we started digging into it. But we're getting close. We refactored some of our local bindings that I wanted to kind of put into our augmented environment, got some of that information in there. We localized a macro, but for some reason the macro didn't actually, the symbol macro and the macro, although the symbol actually exists, we can't use that specific macro expansion inside of our local environment. So that's something that we need to go and look into next time. And finally, for the declaration specifiers, although we can define a declaration specifier, it looks like we can't use it in our CL environment. So I have to go and look into what exactly is going on in there. So next week, hopefully we can clean up some of this stuff and get that in and get a proper augmented environment that has essentially local variables defined, functions defined, and symbol macros, declarations, so that you can actually use them. Well, and hopefully through that discussion, you can finalize your understanding of Parse Macro, which no longer kind of exists. If you go and look at the CL Environments API, it actually has been replaced with Enclose Macro. Although, if you're using a Lisp implementation, Parse Macro should be included in the Lisp implementations that you're using because Parse Macro is part of the Environments API itself. The CL Environments library that we are using, for whatever reason, has hidden the parse macro symbol. and encourages, if you look at the documentation, to use Enclosed Macro instead. So with that, I'm going to close out tonight. I hope all of you are enjoying the code sessions that we're doing here. And if you have any questions, feel free to go ahead and contact me, post stuff in the YouTube comments. Again, like I said, this discussion, this is an ongoing learning experience that we're trying to do. Hopefully, it will provide some information for you all as you are going through it. So until next time,